Hey guys, this video is going to be about mass percent and empirical formulas. It's pretty simple, so let's just get to it. Alright, empirical formula. It sounds like a scary thing, but it's really not. It's really easy. The empirical formula is just a reduced formula. That's the way I like to think about it, but I like fractions, and most people don't, so whatever. But benzene is C6H6, so if we were to look at that and want to know its empirical formula and we reduce it, 6 is the greatest common factor there, so we get C1H1 or just CH. Same for acetylene, C2H2, and I use these two on purpose. You'll see why here in a minute. So they both have the same empirical formula, even though they're completely different compounds. All right. And as a side note, ionic compounds like table salt, lithium nitrate, right? All these compounds, they're already in a reduced form. So you're not going to see an ionic compound that needs to be found in an empirical formula. It's a little bit different for molecular compounds because they can bond together in many different ways as opposed to ionic compounds between ions. All right, so percent composition by mass. The mass of the element divided by the total mass of the compound multiplied by 100 to make it a percent. All right, so we're going to do this first example. What is the percent composition of C6H6? And I want to first find the percent of carbon in the compound. So by using the mass of the element divided by the total mass of the compound, I've got 6 carbons in this compound, right? So each carbon is 12. So we want to figure out how much of the mass of that compound is of carbon. And then the total mass is going to be 78. So that's just the molar mass of the compound, right? We'd have carbon is 12 times 6, which is 72, plus 1 times 6, which would be 78. So this is the total mass. And then we're going to multiply this by 100 to turn it into a percent. All right? And so what you get there is 92.3% carbon. So acetylene or benzene, C6H6, is 92.3% carbon. Now if I do the same thing for hydrogen, I'm going to take 1 times 6 and divide it by 78. Right? And so that's going to be 7.7%, which makes sense because those are the only two things in the compound, so it should add up to 100%. All right, now if we look down at C2H2, what do you think is going to happen? How do you think it's going to be different? Is it going to be different? Remember, they both have the same empirical formula. So if I look at percent of carbon here, I'm going to have 12 times 2 divided by, and this time the mass is going to be 12 times 2 plus 1 times 2 would be equal to 26. So 24 divided by 26 comes out to be 92.3%. All right, and then for percent of hydrogen, you do the calculation if you want, but you do end up getting 7.7%. All right, so this one's for hydrogen and this one's for hydrogen. All right, so if you have two compounds with the same percent composition, they have to have the same empirical formula, period. All right. If they have the same percent composition, they have the same empirical formula. And you can reverse that too. If they have the same empirical formula, then they have to have the same percent composition. So if the percent composition is given to you for a compound, and then they give you a different compound with the same empirical formula, then it would be the same. All right, so if we use percent composition to our advantage, we can figure out some pretty clever ways to do some calculations. So let's take a look here. If I have how many grams of carbon are in 42.6 grams of glucose? Well, you could use what we had used in the previous video with molar mass and molar ratios, and then go back and using the atomic mass for carbon. You can do it that way, but you don't have to if you understand how percents work. So first I'm going to find the mass percent of carbon for this. So the percent of carbon would be 12 times 6 divided by, and the molar mass for this, if we add them all up, so 6 times 12 plus 12 times 1 plus 6 times 16 is 180. Whoops. Okay, and then 12 times 6 of that is just for the carbon. Multiply by 100. And so that's going to be 40% carbon. It's a 40. All right. And then I have 42.6 grams of glucose. Well, if 42.6 grams is all glucose, then 40% of it has to be just for carbon. So if I take 40%, 0.4 of 42.6, that gives me the amount that is carbon in there. And it's going to be 17.0 grams of carbon. So just to make sure you guys remember how to find a percent, here we wanted to take 40% of 42.6, so we multiplied it by 0.4. If you want to take 15% of 50, 15% means it's 15 parts out of 100, so it's 15 over 100. So that would be 0.15 because your decimal place is here, and if you divide by 100, you're dividing by 10 twice, moves the decimal back 2 times. So that's 0.15 out of 50 because it's of 50. So 0.15 times 50 would give you 7.5. So 7.5 is 15% of 50. So anytime you want to take a percentage of something, you just move the decimal back 2 places and then multiply whatever you got times what you want to take the percent of. So the other way to do this would simply be starting with 42.6 grams of glucose, right? Saying there's 180 grams per mole. And then for every single mole of glucose, there's 6 moles of carbon. And then for every mole of carbon, there's 12.01 grams. You're essentially doing the same thing. You'd get the same answer. But sometimes it's easier to do it this way. All right, so next, how many grams of hydrogen are in 500 grams of ammonia, of NH3? So I'm going to take my 500 grams of NH3, right? And first I need to find the molar mass of that, so I can figure out how much of NH3 is actually hydrogen. So 1 times 3 is just the hydrogen, right? That's the hydrogen. And then on the bottom is going to be the total mass of ammonia, which is 17. And then multiply that by 100. And that is 17.6%. Right? So then I'm going to take 17.6% of 500 because 17.6% of ammonia is always going to be for the hydrogen. So 0.176 times 500 is going to be 88.2. So only 88.2 grams out of the 500 grams is from the hydrogen. The rest would be from nitrogen. All right, so that's pretty much it for this. I know it's a little bit different and weird, but it's really not hard, especially if you understand how to use percents. And I implore you, as a consumer in this day and age, to understand how percents work and how to figure out those calculations. All right, so keep practicing and it'll come together.